Space is not empty but filled with a superfine form of matter generated by mass defects throughout the universe. This insight transforms our current understanding of the cosmos. Joseph George's theory on nuclear energy release challenges the traditional interpretation of mass-energy equivalence, E equals mc squared, proposing instead that the energy release in nuclear reactions is due to an explosive transformation of the mass defect into an ultrafine form of matter. Here's a conceptual outline of his explanation for how nuclear energy is released. Mass defect is transformative matter. In standard nuclear physics, the mass defect, the small difference in mass between the original nucleus and the sum of the masses of its fission or fusion products, is directly converted into energy, according to E equals mc squared. George's theory, however, proposes that this mass defect does not directly convert into energy. Instead, he suggests that the missing mass undergoes a phase transition, transforming explosively into an ultrafine, space-permeating form of matter, which he refers to as space-filling matter. Explosive phase transition as the energy source. According to George's hypothesis, the release of energy in a nuclear reaction occurs due to a rapid and explosive phase change of the mass defect. Rather than simply converting mass to energy, this transformation propels the reaction products away from each other, akin to a chemical explosion. The mass defect essentially transitions into a fine form of matter with high kinetic energy, leading to the energetic release observed in nuclear reactions. Analogy with chemical explosions. George likens this process to a chemical explosion, where energy is released through the rapid transformation of substances into gaseous states, causing expansion and dispersal of fragments. Similarly, he proposes that in nuclear reactions, the missing mass explosively converts into fine matter, driving apart the reaction products at high speeds and releasing kinetic energy. This process bypasses the need for mass-energy equivalence, focusing instead on the explosive release due to a change in state. Energy release as kinetic energy of reaction products. The energy observed in nuclear reactions, according to George, is not from mass-energy conversion but rather from the high kinetic energy imparted to the reaction products as they are propelled by the explosive phase change. This means the observed energy output is the kinetic energy resulting from the dispersal of the reaction fragments due to the transformation of the mass defect. Role of space-filling matter in nuclear processes. George's theory suggests that the space-filling matter produced in the reaction contributes to the energy released by facilitating the explosive process. The newly formed ultrafine matter interacts with the surroundings and with the reaction fragments, enhancing the dispersal effect and leading to a release of energy that mimics what is typically attributed to mass-energy conversion. Implications for astrophysical and cosmic phenomena. George extends his hypothesis to suggest that this process of mass defect transformation into fine matter is a universal phenomenon, potentially occurring throughout the cosmos. He speculates that the continuous generation of space-filling matter from mass defects in various reactions contributes to large-scale cosmic phenomena, influencing everything from stellar explosions to the formation of galactic structures. Potential applications and experimental validation. To validate his hypothesis, George has proposed experiments involving highly sensitive measurements of nuclear reaction products, such as immersing californium-252 in water to detect any unusual kinetic behaviors, shock waves, or fine matter formation that deviate from expected decay patterns. These experiments would aim to observe the effects of an explosive transformation of the mass defect, distinct from the predictions of mass-energy equivalence. Revolutionary implications for nuclear physics. If validated, this theory could radically shift our understanding of nuclear energy. Instead of relying on mass-energy conversion, nuclear reactions would be understood as events where mass defects transform into space-filling matter, producing energy through kinetic dispersion. This alternative view could potentially lead to new insights into nuclear reactions, energy generation, and applications in propulsion technology. In summary, Joseph George's explanation for nuclear energy release is that the mass defect in nuclear reactions explosively transforms into an ultrafine form of matter, rather than converting directly to energy. This explosive phase change imparts high kinetic energy to the reaction products, leading to the release of energy observed in nuclear processes. This theory challenges traditional interpretations, proposing a new framework for understanding nuclear reactions and the nature of energy release.